Hi, and welcome to freenetworkstudy.com. In this ospf lab, we'll configure different ospf network types, and we'll be focusing on point-to-point and point-to-multipoint network types. These two network types don't support the election of a designated router, and therefore are compatible. Looking at the requirements list, we have to enable ospf on all routers, make sure all connected interfaces are advertised into ospf, and make sure that we do not use any designated router network type in our setup. So starting on router 1, show IP protocols. ospf is not enabled currently on the router. Configure terminal, router ospf 1. That enables ospf. Now to enable ospf on the various connected networks, use the network keyword, network 10.1.1.0/24 in area 0, sorry. Now we have to configure router 1 serial 00 with an IP ospf point-to-multipoint network type. So interface serial 0/0 IP ospf point network point to multipoint. Now jumping on router 2, show IP protocols, configure terminal, router ospf 1. And we're told to use only one network command on router 2 and 3. So in order to cover all connected interfaces, we'll use the 0.0.0.0/0 network. So network 0.0.0.0/0 area 0. Now let's do the same thing on router 3. Show IP protocols, configure terminal, router ospf 1, network 0.0.0.0/0 area 0. Right, so ospf is enabled on all routers and all interfaces. Let's jump to R1 and have a look at the ospf neighborships. Show IP ospf neighbors. Okay, so R1 seems to think his neighborships to the router 2 and 3 are fully loaded. Then we should have IP routes. Show IP route ospf. Yet IP routes are not being exchanged, and that can be a bit tricky, since we think the neighborships are up, but in fact nothing is happening. The reason for that is that the routers are running non-compatible ospf network types. Let's confirm that on router 1. Show IP ospf interface serial 0/0. So the interface is up. The network type is point-to-multipoint. The hello timer is 30. On router 2, show IP ospf interface serial 0/0. We see that the hello timer is matching 30, but the network type is non-broadcast, and therefore implies that a designated router is to be elected. Yet R1 knows nothing of a designated router, and is therefore unable to set up an adjacency with the pseudo node created by the designated router, and this is why you don't have any routes exchanged. Now to fix the issue, we're told to use a compatible ospf network type on routers 2 and 3. So what would be a compatible ospf network type? Well, obviously a network type that doesn't support designated router election. These are point-to-multipoint and point-to-point. Let's use point-to-point network type on routers 2 and 3. On router 2, interface serial 0/0 IP ospf network for network type point-to-point. Now we know that network types point-to-point and point-to-multipoint are compatible. So why is it that the neighborship is not up? Let's have a look at the ospf parameters on this interface. Do show IP ospf interface serial 0/0. Okay, so the network type is now point-to-point, and there's no mention of a designated router. However, the hello timer is now 10, which doesn't match the hello timer on router 1, which was 30. In order to make that neighborship go up, we would have to make them match. Let's do that on router 1, so we only have to do it once. Configure terminal, interface, serial 0/0, IP, ospf, hello interval, and 10 to match the timer of routers 2 and 3. Now we don't have to configure the dead timers, since it's per default 4 times the hello timer, and we see a neighborship with router 2 coming up. Now jumping on router 3, show IP ospf interface serial 0/0. We're still running the ospf non-broadcast network type, and as we know, this is not compatible with the point-to-multipoint network type. So let's change that. Configure terminal, interface, serial 0/0, IP ospf network type, point-to-point. Now we see a fully loaded adjacency between the routers. Let's have a look at the IP routes on router 1. Show IP route ospf. Now we see routes being exchanged between the neighbors. Show IP ospf neighbors, and we confirm that the neighborships are up. Show IP protocols, and here we see something quite interesting. Over here is that I just forgot to enable ospf on the loopback interfaces. Let's do that. Conft router ospf1 network 1.1.1.0/24, and network 11.11.11.0/24. Just want to confirm real quick that these subnets are configured on router 1. Do show IP interface brief. Okay. Do show IP protocols. Okay. Now we see that we have ospf enabled on all interfaces. Okay, back to router 2. Show IP route ospf. And now we seem to have a propagation of all the routes. Let's try to ping route 3 from here. Ping 3.3.3.3. That's working. We have one last requirement, and that's to make sure that all loopback networks are advertised with the network mask configured on the interface. And looking at the routing table, we see that this is not currently the case. Those loopback interfaces were configured with a /24, yet they're advertised with a /32 mask. This is due to the fact that when enabled on loopback interfaces, the default ospf network type is loopback, and as a result, subnets configured on loopback interfaces will always be advertised with a /32 mask. To make sure the real mask is advertised instead of a /32, we would have to go in the interface configuration mode and change the default ospf network type from loopback to point-to-point. Configure terminal, interface loopback 0, IP ospf network point-to-point. On loopback 1, same thing. On router 1, interface loopback 0, IP ospf network point-to-point. Loopback 1. Now to router 3. Interface loopback 0, IP ospf network point-to-point. And on loopback 1. Okay, let's go back to router 2 and check the IP routing table. Show IP route ospf route. Great. Now we see that the loopback subnets are advertised with their real masks /24. To be safe, let's verify that we still have end-to-end IP connectivity. And let's try to ping router 1 and router 3 from here. Ping 3.3.3.3. That's working. And 1.1.1.1. That's perfect. And that was it. Thank you for watching.